Good morning, everyone. I'm Uma Latha, Assistant Professor, Department of Information Technology, Tech Multitech, Dr. Rangarajan, Dr. Shakuntala Engineering College. I'm handling the subject Healthcare Data Analytics. Here we are discussing about the topic Machine Learning Foundations, Tree-like Reasoning. Tree-like reasoning. Tree-like reasoning refers to a logical decision-making process that mimics human thought by breaking down decisions into a sequence of questions or conditions arranged in a tree structure. It is mainly used in decision trees and related models like random forest and gradient boosted trees. A model learns to split the input space based on features formed in a tree, where each internal node represents a test on a feature. Each branch represents the outcome of the test. Each leaf node represents a decision or output. Decision tree. Simple definition of a decision tree. A decision tree is a game of 20 questions or yes or no quiz where you answer questions step by step and it tells what to do or what something is. Here, an example, what should I eat for a snack? Child is trying to decide what snack to eat. The first question, each question acts as a decision node, each answer acts as a branch, going to the next question or result. Find result. Here, are you hungry? If it is yes, is it close to dinner? Is it close to dinner? If it is no, then play outside. Is it close to dinner is another one question. If it is yes, eat fruit. Otherwise, eat cookies. First question, are you hungry? If no, then go play outside. You don't need a snack. If yes, then check the next question. The next question is it close to the dinner time? If yes, eat something like food. If no, you can enjoy a cookie. Each question is like a decision node, each answer is like a branch, and the final result is the leaf or outcome. Splitting criteria. In a decision tree, a splitting criterion is how the computer decides which question should I ask first, which feature is the best to divide the data. It wants to split the data into groups that are as pure as possible, like grouping similar things together. The computer uses splitting criteria like gene impurity, entropy, information gain to mathematically measure how pure each split is and then choose the best question that is feature to ask next. College. College example. Try to predict whether a student will pass or fail based on some feature like attendance, study hours, and assignment submission. The goal is to use a decision tree to split students into pass and fail groups. Here's the tabular column for the student data, attendance, study hours per day, assignments done, and the result. Which feature should the tree use? First, to split the data. First split. Is attendance greater than 75? Is attendance greater than 75? Then the result is pass. Yes. Greater than 75? Yes. So the result is pass. Next, it's a good split. One group mostly passed, other who failed. Second split. Second split, did the student complete assignment? Yes. All passed. All passed, pure group. All failed, also pure. This is an even better split because both groups are 100% pure. So this question gives the highest information gain, that is lowest impurity. The concept splitting criteria meaning rule used to pick the best feature for splitting. The goal is to create groups while the outcome is as same as possible. Example, did the student complete assignments give perfect separation? Training a decision tree. Training a decision tree means teaching it how to make decisions using examples that is labeled data, just like teaching a child with practice questions and answers. For example, training a decision tree to predict pass or fail. If the assignment is done, yes, pass. If it is no, fail. The split is pure on both sides, so the tree stops here. The training the tree step by step. The tree looks at all the feature and decides which feature give the best split. Let's say it chooses assignment done because all students who did assignment passed and those who didn't failed. Now it splits the data. The split is pure on both sides, so the tree stops here. Prediction. Prediction in a decision tree. After the tree is trained, it can make predictions for new situations by following a path. For example, predicting pass or fail. You already have a trained decision tree like this. Did the student submit assignments? If it is yes, then go to the next question. Attendance greater than 70 percentage. If it is yes, then pass. If it is no, the attendance greater than 70 is no, not, that is fail. Okay, example 1. New student info. Assignment submitted, yes. Attendance 85 percentage. Prediction path should be start at root. Assignment submitted, yes. Next, attendance greater than 70, yes. The prediction is pass. Then the second example, new student info. Assignment submitted, no. Prediction part, assignment submitted, no. So prediction is fail. The tree doesn't even check attendance because missing assignment is alone is enough to decide. Step, what happens? Start at the top question, that is read no. Then second one is the check the student's features, that is attendance or assignments. Third one is the follow the yes or no path down the tree. Final one, reach a leaf node. Example, pass or fail. The result at the leaf is a prediction. Then the ensemble methods, and the four ensemble methods are bagging, random forest, boosting, and gradient boosting. Bagging. Bagging uses many learners trained on random samples of the data. Each learner makes a prediction. The results are combined, that is by voting or averaging, to improve accuracy and reduce mistakes. Why it helps? Why the bagging is helps? One student work may miss something, but combining all gives a better result. For example, bagging, bootstrap aggregating, drawing a picture with many artists. A teacher gives a task to the students. Draw a picture of a house. Instead of asking just one student to do it, but she asked five different students. Each student gets a slightly different version of the instruction. Some parts repeated, some missing like draw windows, draw roof, etc. Every student draws their own version of the house. Then teacher looks at all the drawings and combines the best parts to make a final picture. The final house drawing is better than any single one because it uses ideas from all the students. Then second one is the random forest. What the computer does, it builds a forest of decision trees, each trained on random data and random features to prevent overfitting and give better answers together. Random forest, a forest of smart friends. Here is a story. You have a question like, should I bring an umbrella today? So you ask 10 different trees, that is friends, in a forest. Each tree saw different parts of the weather. Some saw clouds, some saw temperature, some saw wind. Each gives their own answer. Then you take a vote. Majority wins. The simple point is you ask many different trees and trust their good decision. Third one is the boosting. What the computer does. It trains models one after another, each one trying harder to fix what the previous ones missed. The final result is a smart mix of all the learners. A story here. A group of students learning from mistakes. Let's say a class of students is solving math problems. The first student makes a few mistakes. The next student focuses only on those mistakes and tries to fix them. The next one again tries to fix what's still wrong, and so on. At the end, the teacher combines all their answers and giving more credit to the student who got tricky parts right. Final one is gradient boosting. Each new model learns from the remaining errors. Add many small corrections step by step. The final result is highly accurate. Gradient view boosting. Fixing homework mistakes bit by bit. You finish your maths homework, but your teacher says you made some mistakes. You look at the paper and fix the first few errors. Then you check again. Still a few more errors remains. You fix those too, slowly and carefully. After a few rounds of small fixes, your homework is almost perfect. Each time you are correcting what's left wrong, not starting over. Advantages of tree-like reasoning. Interpretability. That is, show your work. The story is, imagine you're solving a math problem and the teacher asks, how did you get the answer? You show each step, what you added, what you subtracted, so your teacher understands how you got the final answer. Decision trees are like that. They show every question and answer along the way, so we can see and understand how they made a decision. Here, the key point is you can trace the path from question to answer, just like showing steps in homework. Non-linearity. Rules can change. Here the story is let's say you are playing a game. Where if you are under 10 years old and like drawing, you go to the art room. If you are over 10 and like science, you go to the lab. These rules are not in a straight line. They depend on different things and changes based on choices. Decision tree can handle that. They don't need straight rules like older equal to better. They can handle mix up logic based on the situation. Here, the key point is trees can make decisions that are not just bigger is better. They can follow if then rules like in games. Third one is the handling missing values. Handling missing values. Skipping a question. The story is in a quiz. If you don't know one question, you skip it and still go on to answer the others. Decision trees can do that. If a student if a student doesn't know If the student doesn't know, do you have homework? The tree can still decide based on other answer like attendance or study hours. The key point is even if one piece of information is missing, the tree still works. The fourth one is the ensemble benefits. Ensemble benefits, team project is better. The story is your class is doing a science project. Instead of one student doing it all, everyone contributes their best ideas. One does drawing, one writes the report, and the one presents. The final project is better than any one student could do alone. Ensembles like random forest or gradient boosting work the same way. They combine many trees to make stronger and smarter model. The key point is teams of trees give more accurate answers than a single tree. The final one is the feature importance. Feature importance, which clue helped the most? Story behind this. You played a guessing game and figured out someone's favorite color. Afterward, you think, the biggest clue was when they said, I love the sky. They told me it's blue. Trees do this too. They tell us which features or questions were the most helpful in making the decision. Key point is we can see which feature, like age, marks, attendance, was most important in prediction. Here, the advantages of tree-like engineering concept, interoperability. You can see the steps of the decision. That is example showing math steps. Non-linearity. The rules change based on choices. Example game rules. Handling missing. Can still guess even if one answer is missing. Example. Example. Skip the question. Still play. Ensemble benefits. Teamwork makes the result better. Team project in school. Feature importance. Know which clue helped the most. Sky is a hint. Color is blue. Thank you.